Hi, my name is Parisa Ghanotorshizi and I'm presenting our paper, Large Language Models for Virtual Human Gesture Selection. Well, gestures are an integral part of our everyday face-to-face interactions. They can convey a wide variety of meanings. They can also impact, for example, the persuasiveness of the speaker and the recall or engagement in the listener. One example of such gestures is the container image schema that represents an abstract set, with metaphoric gestures revealing cardinality of the set,
Is there anything that,
removing elements from the set,
besides what he wants,
adding elements to the set,
putting a little bit of contribution from each into a trust fund,
and the union of subsets or elements of the set.
Republicans and independents and Democrats who are open-minded, who were there for...
Because of their importance, these gestures have also been incorporated into the behavior of virtual humans or robots that are designed for different contexts or as different roles. For example, virtual humans as mental health clinicians or virtual humans for training social skills. But the question that arises here is that how can we get this rich gesturing that we see in humans that is also appropriate to the context of the speech and the role of the virtual humans? In recent years, there has been an extensive work on data-driven machine learning approaches for gesture generation that rely on extensive annotated data to acquire a mapping between utterances and gestural motions. However, these approaches produce a statistical average over all gestures, ignoring that individuals in different roles gesture differently. For example, politicians, comedians, clinicians, they all gesture differently. So our paper proposes LLMs as a solution to these challenges and demonstrates that LLMs encode rich knowledge of human gestures, from abstract knowledge on image schemas and types of gestures to more specific knowledge on how different roles gesture or even how different well-known individuals gestures. So critically, what an LLM supports here is a prompting that allows for individualization and role specification that we are looking for in our virtual humans. We then evaluated our gesture selection approach on a data of an actual speaker. The results of this evaluation was carefully judged by gesture experts. So in our evaluation, we assessed alternative prompting approaches where the LLM was prompted with variations of a description of gestures and examples of gestures used in an actual utterances. The results that were then evaluated based on the semantic appropriateness of the gestures. And as you can see in this figure, the gestures are highly appropriate. We then took the approach that was suitable for the purpose of being paired with an animation system, and then we implemented this gesture selection system within the whole virtual human framework, which is demonstrated in the paper. Here is also a demo of how the system is performing.
This is within our scope.
In conclusion, overall, the semantic appropriateness of gestures was very impressive. Also, we observed that alternative prompting approaches are suitable for different uses. For example, prompting the LLM with no prior information on gesture would yield gestures that are creative, novel, and more flexible. This can be used to suggest gestures to the designer and can be used in the design phase of a gesture generation system. However, when the LLM was prompted with prior information on gestures, it would come up with gestures that are constrained to the provided list of gestures. This can be used in automating gesture selection and ensuring the personality and role consistency in gesturing of the speaker or the virtual human. Thank you very much for listening.